Good day, everyone. Today, for this video, we are going to discuss random variable. Good day, everyone. Today, for this video, we are going to discuss random variable. And to start with our discussion about a random variable, let us have first the recall of the lesson. And this is all about probability. Now, I do have here 5 descriptions at the left side and then 5 options at the right side. We are just going to match the descriptions stated at the left side corresponding to a certain word written at the right side. Okay, now to start with, let us go first with the given first description, that is an activity which can be done repeatedly under similar condition. That is what we call experiment. Okay? Therefore, if you are going to deal with a concept of a certain activity, for example, you flip a coin and then you roll a die. That is what we call an experiment, okay? Or an activity. Yan. Next, the second one is the set of all possible outcomes in any experiment. What will be the possible outcomes in a given experiment? And we are dealing with the set of all possible outcomes, and that is what we call sample space. Okay? Now, sample space is the set of all possible outcomes in any experiment. Meaning, if you are being asked for what are the possible outcomes in an activity or in an experiment, therefore, you have to provide all the possible outcomes. For example, when you flip a coin, as an experiment, therefore, what will be the outcomes? Now, the outcomes can either be head or tail. If you are going to list all the possible outcomes in a given experiment, then that is what we call sample space. Okay? And if we do have the sample space, then we do have a certain what we call subset. And that subset of a sample space is what we call event. We are dealing with a specific activity in a given experiment. For example, you flip a coin and you consider of what will be the probability that tail will appear? Or you are dealing with, is there a chance that head will occur? Okay, therefore, the event that you are talking about is now is specific relative to the given experiment. Okay, and then we also have the elements in a sample space, and this is what we call the outcome. Okay, and the last one is if we are talking about the ratio of the favorable outcomes to the number of possible outcomes, then that is probability of an event. Okay, to sum it up, when we talk about a particular activity in a given condition, therefore that is an event. While when you are performing an activity, then that is experiment. Okay? And if you are considering what are the list of possible outcomes in a given experiment, then that is the sample space. Okay? And whatever be the outcomes or elements in a given space, you have to consider it because at the end, you are going to look for what is the chance that that particular event will occur in a given experiment. And that is probability of an event. Okay. Now, these are the lessons that you um, encountered during your junior high school. Okay. And these concepts will be utilized in our preceding lesson. Okay. And since we are talking about random variable, let's go with an exploratory concept. Okay. Now, suppose two coins are tossed and we are interested to determine the number of heads that will come out. Okay. First, going back with our terminologies, we do have tossing of two coins, and that is an experiment. Okay. You toss a coin or tossing of two coins, therefore, that is an experiment. But you deal with a specific task, and that is determining the number of heads that will come out. Therefore, you are talking about event. Okay. And the event here is dealing with the number of heads when you toss two coins. Okay. Therefore, first, we have to consider what will be the outcomes, okay? So that we can determine the number of heads that will occur during the flipping or tossing of coins, okay? Now, for the first toss, we do have either head or tail, meaning there will be a possibility that when you toss a coins, therefore, it can be head or tail will occur. Next, when you flip another coin, then there is a possibility that head or tail will occur. Or another one, by chance, it can be another head or tail. Okay, depending on the given pairing. Therefore, looking or observing our illustration for the first toast, or if you are going to flip the coin, now the chances or the possible outcome that will occur can either be head or tail. When you flip or toss the second coin, then there is a possibility that head or tail will also occur. Okay, based from the illustration that we have, now let's go with the outcome. Okay, now the outcome can be flipping two coins or tossing two coins. It can be head and head, meaning to say, if you flip two coins, now the possibility that an outcome will appear will be head and head, or it can also be head tail. Okay, or it can also be tail head or tail tail. Therefore, from this concept, going back with the number of heads that we are dealing with as our particular event, therefore, for the first pairing, we can have two heads. For the second, we can have one head. For the third, we can have one head. And for the last, we have zero. Therefore, the number of heads will be 2, 1, 1, 0. Okay? Now, from here, we can go with what is our sample space. Now, looking back from the list of possible outcomes, now the head or the head tail tail is or are our list of outcomes. And that will be the sample space. Okay. And then going back with our main concept, that is to look for the number of heads in each outcome and assign this number to this outcome. Therefore, we do have 2, 1, 1, 0. Okay? Therefore, based from the outcomes that we have, which are head, head, we have two heads. Head, tail, we have one head. Tail, head, we do have one head. And then we do have tail, tail. Therefore, we do have zero or none for the number of heads, okay, relative to the last possible outcomes. Okay, now, as you can see, we do have 2, 1, 1, 0. These are the value of the number of heads, okay? And from here, now our answer will be 0, 1, and 2 corresponding to what are the values of the random variable in the experiment. Okay? And 0, 1, and 2 are what we call the random quantities. And these were determined by the outcome of an experiment. I repeat, 0, 1, and 2 are what we call the random quantities. These random quantities are the number of heads based in our experiment. And these were determined by the outcome of an experiment. And we assume that our variable here or the random variable is h relative to the question. Okay? Therefore, from that concept, let's go with what is the definition of random variable. Now, random variable is a numerical quantity. 0, 1, and 2 are the random variable that we assign to the given number of heads from the previous activity. I repeat, random variable is a numerical quantity that is assigned to the outcome of an experiment. Okay? And based from our previous activity, our variable there were 0, 1, and 2 from the given number of heads that occur when we toss or when we flip two coins. Okay? And remember, we use capital letter to represent a random variable. To represent a random variable, we made use of letter H in our previous example. But mostly in some of the books, they are using X, capital X, as a representation for the random variable. Okay? I repeat, random variable is a numerical quantity that is assigned to the outcome of an experiment. Numerical quantity. Okay? Now, to further learn our lesson for this video, now let's go with example number 1. Okay? Now, we do have 4 red jolens or the marble balls, and we do have 3, and then we do have the urn. We are going to place these 7 jolens or balls inside the urn. Okay? Now, 2 balls are drawn in successions without replacement from an urn containing 4 red balls and 3 blue balls. Okay? Now, our concept here is to deal with two, two balls, okay? And then the possible values of x or the values x of the random variable x capital, where x is the number of red balls, are, meaning to say, in this example, we are considering two balls to be collected, but to be specific, we are just dealing with the red balls. Okay, therefore, there are only two colors present. We do have the red and we do have the blue. But the specific concern here is the red one. And we are looking for what will be the number of red balls if we are going to, okay, to what? To drone, okay, 2 balls from the given urn, okay, without any replacement at all. Okay? Now, same concept. We do have the first draw. Now, it can either be red or blue, meaning to say you can pick the red or you can pick the blue. Okay? For the second draw, it can either be red or blue or another red or blue as a pairing. Therefore, the outcome will be, for the first draw, it can be red. For the second, it can also be red. Or it can be red and blue. Or it can be blue and red. Or it can be blue and blue. But since we are talking about the number of red, therefore, this will be our answers. Okay? Or answer. We have two red. Next, one red. Next, another one red. Next, zero. Okay? And from here, we use our sample space, RR, RB, BR, BB, and then our answer will be 2110. Okay, representing the number of red. And final answer will be 0, 1, and 2 as the value or the random variable for the number of red. Another example that we have is our example number 2, but this time we will be using tahong and talaba. Tahong, also known as mussels, and talaba, also known as oyster. Now, in this case, we are dealing with the problem. A basket contains 10 tahong and 4 talaba. If 3 shells are taken from the basket, one after the other, determine the possible values of the random variable x representing the number of tahong. Okay? Now, in this case, we are using the random variable x. Okay? And we are going to what? Uh, uh, take 3 shells from the basket containing 10 tahong and 4 talaba. Okay? But our concern here is to look for the random variable x where x represent the number of tahong. Okay? Yan. And then we go with our note here. Let x represent tahong and y represent talaba. Okay? Now list down the outcomes. We can have XXX, XXY, XYX, YXX. Okay, what does it mean? Tahong, tahong, tahong for the first one. Tahong, tahong, talaba. Tahong, talaba, tahong. Talaba, tahong, tahong. Okay? Or it can be YYX, YXY, XYY, YYY. Okay? That is talaba, talaba, tahong, talaba, tahong, talaba, tahong, talaba, talaba, and talaba, talaba, talaba. Okay, and from the list of outcomes, okay, that we have, now we go with counting the number of tahong in each outcome and assign the number to the given outcome. Okay, that is, we do have now the table and we do have the outcomes. Okay, now since we are talking about or we are just dealing with the value of tahong, therefore we are just going to count the number of x present in the given outcome. And our answer will be, for the first outcome, it's 3. For the second, it's 2. Another 2. For the third outcome. For the fourth outcome, it's also 2. For the fifth outcome, we have 1. Next, another 1. Next, another 1. And 0. Therefore, the number of tahong or the value of x will be 3, 2, 2, 2, 1, 1, 1, 0 for the given 8 outcomes. And then, what are the values of the random variable x or the number of tahong in the experiment? Okay, therefore, what will be our answer? Our answer will be 0, 1, 2, and 3. Okay, remember, the random variable here in our experiment are 0, 1, 2, and 3. Okay, now with this, Let us first go back with our definition about random variable. A random variable is a numerical quantity that is assigned to the outcome of an experiment. And remember, we use capital letter to represent a random variable. And with this, I hope you learn about the concept of the random variable. And in our next video discussion, we are going to deal with the classification of random variable in the given situation. Goodbye and God bless everyone. See you in my next video learning about classifications of random variable. God bless. And if you are not yet subscriber in my YouTube account, please do subscribe and click the notification bell for a more uploads. God bless.